Sounds like a threat.
So, today we are going to be starting the second half of Chapter 7, which is on factoring. And it does tend to be a difficult unit for a lot of people. So that's why I would really advise that you take good notes today, and pretty much for this entire unit. I've kind of broken it down into smaller sections than what the book has because that will make it a little bit easier for you guys. But because of that, my numbering for the sections isn't going to be perfect, and I'm going to probably just not do some section numbers for this. I'll just kind of put the heading at the top of what we're going to be doing, so you can organize it that way. So today, we're going to talk about factors and the GCF. Okay. We are going to go over some vocab today. All right, so first off, I want to talk about what is a factor. So does anybody have any ideas?
Number.
More specific.
Numbers that go into a certain number.
So what if I said, give me the factors of 10?
5 and 2 and 5.
They're numbers that go into 10, right? Evenly. So that would be 2 and 5, and also 1 in itself, right? 1 and 10 would all be factors of 10. So factors, or a factor is a number or an expression that divides another number or expression evenly. So just to do a couple examples of that, 2 and 6 would both be factors of 12 because they divided evenly. Now those aren't the only factors. There's going to be multiple factors of 12. But would 5 be a factor of 12?
No.
No, it does not divide it evenly. Okay, that's with just basic numbers, and you guys should be good with that. You guys have talked about factors before. That should be pretty straightforward. What we're going to start talking about today is when we're dealing with factors of algebraic expressions. Okay, but the same concept applies that they have. If we're talking about an expression that divides another expression evenly. Okay. So, for example, if I gave you something like 8x, what would be factors of that? So, 2x is a factor of 8x. Yeah, you could also, there's going to be lots of factors here. Just a number by itself would also be a factor of 8x, right? I could say 4 is a factor of this, right?
Yeah.
Okay. What about just x by itself?
Yep.
Yes.
Yeah, those would all be factors. Okay. I want to go maybe one step farther and give you something. I'm going to kind of give you this number first. But if I give you something like 8x to the third, okay, what would be a factor of 8x to the third?
4x to the third.
No.
Be 2x to the second.
You have to do it.
Yeah, I could have lots of different options, but something like, let's say, would 4x squared be a factor of 8x to the third?
Yeah.
Yes, it would.
Time to do it.
Wait.
because this would divide this evenly. And another way of thinking about it, and I find this particularly helpful in this chapter, is there something that I can multiply this by to get this? 2x. Okay. Yep. Okay. So the next thing that we need to talk about is the GCF. GCF is an abbreviation that we're going to use a lot for greatest common factor. Okay. And again, that's something that you guys should be comfortable with. You've done it a lot with just regular numbers in other math classes, but we're going to take those concepts and then apply it to algebraic expressions. Okay. So the directions, and this is actually what you guys are going to be doing on your homework today, is you are going to be finding the greatest common factor. And to find the greatest common factor, you have to be given two things, right? It has to be the greatest common factor between two things. So your directions, find the GCF. And for number one, we are going to find the greatest common factor of 6x squared and 9x.
3x.
Okay. So I look at the numbers. I'm always going to have the GCF of 6 and 9, which is 3. But then we also have to look, what's the greatest common factor of x squared and x? It's just x. Okay. I can't go any bigger than x, like with an exponent. I can't have x squared because x squared isn't a factor of both. Does that make sense? Okay. So my GCF of those is just going to be 3x. Okay. For number 2, (4x to the third) and 12x to the fifth power. So what I usually do here, I start just looking at 4 and 12, because you guys know how to do that. The GCF of 4 and 12, the greatest common factor, there would be 4, right? Is everybody okay with that? And then when I look at my variables, it has to be x to the third, right? X to the third is a factor of itself, and it will also go into x to the fifth, right? Okay. I can't go any higher than x to the third because it wouldn't work for this one. So what you will end up noticing on your variables, the GCF is going to be the least common exponent, right?
Are we gonna get homework today?
Okay, so what I'm saying here with the variables, 3 doesn't go into 5, not by multiplying, but with your exponents, I'm saying that x to the third is a factor of x to the fifth, because I can multiply it by something to get x to the fifth. Right? With your variables, any exponent is going to be a factor of that same variable with any exponent that's bigger than that. So what that means is like, hey, x to the 7th is a factor of x to the 8th, because I can just multiply it by an x. Does that make sense?
Yep.
Okay. For our next one, we're going to go up a little bit. We've got 16x to the second y and 20xy. Yep, so look for the GCF of 16 and 20. That would be 4. And then when I look at, I would just go variable by variable. So x squared and x only have a GCF of 1x. And then they both have a y in common. So my GCF would be 4xy. And I can also think about it, I can take this factor and multiply it by something to get both of these. It is a factor of both terms. Let's see here. So if the numbers have nothing in common, or 17 is prime, but they still have a common factor of 1, right? And then I also have some variables in common. So they have 2 x's in common, right? And since you could put 1 x squared y, if you have variables though, I would like you to get rid of the 1 for your final answer. If there is absolutely nothing in common besides a 1, you would just put 1. Okay? Okay, so when I'm looking at the GCF of 18 and 36, make sure you get the greatest common factor, which would actually be 18. Okay? 9 is a common factor, but it's not the greatest. And then when I look at m to the 5th and m to the 3rd, my GCF there would be m to the 3rd. And they don't have any n's in common, so I can't put that in my GCF. Okay.
Why do you just have an empty bottle?
Because I drink it all.
All right, so what is the GCF of 25 and 16?
One.
Just 1. But if they have any variables in common, I'm not going to put the 1 because I just need to reduce it. They have 1 x in common.
And then Z.
They have no y's and 1 z. So all that they have for a GCF is just variables. Okay. If you put a 1 there, just get rid of it for your final answer.